Welcome to Spring LIB.
This is the answer to Chapter 31, problem number 38 from the Smith Organic Chemistry textbook. And in this problem, we're asked to make comparisons between different polymers. So I've gone ahead and redrawn each of the polymers that we're asked about. We're also given the glass transition temperature and the melt temperature for each of these polymers. I did not rewrite that information, but it is right there in the problem. So for A, we're asked to compare we're asked to explain the differences in the observed glass transition temperature and melt temperature between polyester A and PET. So when we look at polyester A and PET, we see that there are some differences in the polymer chains. So polyester A has lower Tg and lower Tm than PET because its chain is more flexible. So PET has benzene rings, and so the benzene rings in PET confer a degree of rigidity. So PET has aromatic rings. And so, again, they confer rigidity. And so the more rigid the polymer chain is, the more ordered it's going to be, and the higher its Tg and Tm are going to be. So that explains the difference between polyester A and PET. So for part B of this problem, we're asked to make the same comparison, but between polyester A and nylon 6,6. So this time, polyester A again has the lower Tg and Tm. And of course, now neither of these has aromatic rings. So we can't say that it's due to the rigidity of the aromatic rings. But what we can say is that nylon 6,6 has nitrogens with hydrogens attached. So I'm going to go ahead and point them out. And so nylon 6,6 has these, and as you can see, polyester A does not. And so the benefit of these is that they allow for hydrogen bonding. So I'm going to say NH allows for hydrogen bonding. So whenever we have H bonds, of course, two comparable molecules where one can hydrogen bond and one cannot, the one that can hydrogen bond is going to have much, much stronger intermolecular reactions. So in this case, the chains are able to strongly interact with one another, and that grants a much higher degree of order to the nylon 6,6 polymer. So that explains why nylon 6,6 has higher TGs and TMs than polyester A. And so lastly for this problem, for part C of this problem, we're asked how we would expect the TM value for Kevlar to compare with the TM value for nylon 6,6. And we're asked to explain that prediction. So I've drawn Kevlar out. And so just based on what our answers for A and B were, so Kevlar has both features that we mentioned in parts A and parts B. In part A and part B. So Kevlar has aromatic rings, which again confer rigidity. And it also has NHs that can do nitrogen bonding. So both rings and H bonds. So it has both of these order conferring characteristics that we noted in the two earlier parts of this problem. And so nylon 6,6 only has H bonds, So Kevlar has H bonds and rings, and so therefore we would expect its TM to be higher than nylon 6,6s. And that's the answer to chapter 31, problem number 38.